Okay, so for Math 3, make sure you have your Unit 8 Objective 3 notes out. So we're going to be continuing on with this. So what we did on Thursday last week is we did the standard deviation, and we did that pretty quickly. But just to kind of remind you, this is kind of our setup here, right? So we basically are subtracting each of our data values with its average, and then we square it. And we go all the way through with each data value. We have to subtract it from its average and then square it. And then once I get these numbers, I average those, right? Find those average, and that gives me what's called the variance. And then when I take its square root, that gives me the standard deviation. And the standard deviation just kind of describes the spread of the graph, meaning how far away from the average are you in general as a class. And so you would expect Elvira's to have a small standard deviation because all of her scores are close together, right? So all of her scores are close together. So Bob's scores, you would think, would be a lot further apart. So we're not going to actually do this example, but what I am going to tell you is what the standard deviation is for Bob. So Bob's standard deviation, so that symbol is kind of a circle with a line or a tail on it. So Bob's standard deviation is 5.6, right? And this was Elvira's. And so that means that Bob was, his test scores were further apart from each other, so his standard deviation should be larger because he would be off from the average by quite a bit. And remember that his average from previous objectives was 76. So his average was 76. So on average, he's about 5.6 away for each of his test scores, right? Now, he's not for each one, right? So if he had a 99 and he averaged 76, he's definitely 23 points away. But when he scored a 75, he was only 1 point away. Okay, so that's kind of what our standard deviation is. So let's flip to the back side right here. So we're going to just talk about this little box right here that we have to know. So we're not going through all the little pieces, but just to kind of make sure we understand what's happening here. So this is our average, this is our standard deviation. So if we increase all of our data points, so if we increase all of our data points by a multiplier, meaning if someone got say a 4 on their score, but I wanted it to be worth 40 points, 5, and I wanted it to be worth 50, 6, and I wanted it to be worth 70 or 60. So if I multiply each of these values by 10, that means my average is going to go up by that same multiplier, right? So if I multiply the data, so this is the data values, by 10, then my mean will also increase by 10, or times 10. And that's the same for if I add a value, right? So if I want to change the grade by adding 5 points to everybody's score, that means the average is going to go up by that as well. So my average will also increase by whatever that is. So I would add the increase or decrease, right? If it turns out to be a negative, then I would subtract it. So as I multiply everybody's value by 10 or whatever, their average all goes up by that same, multiplied by 10, and that spread will also increase. So I would also change this by multiplying. And I'm just going to use that value for C, meaning whatever change I'm making. But the spread will not if I add, because if I increase everybody's score by the same amount, the spread of the data does not change as well. And so this is the only one where there will be no change. Everything else will change. The average will go up by whatever. The standard deviation here will go up by whatever. But the standard deviation, this one right here, does not change if I increase everybody's value by the same amount, because it would not change how far apart those scores are, right? So for example, if I had original scores of 4, 5, 6, 7, and I increase this person's score by 3, and so on down the line. So originally, these people were 1 away from each other, right, all the way down. 1 away, and they stayed 1 away from each other, right? The person who got a 4 now has a 7, is only 1 away from the person who got a 5 still, right? Because then they got up to an 8. But what if I multiplied, right? So 40, 50, so I'm multiplying by 10. So if I look here, this person was only 1 away from each other, right? But now how far apart are they? They're now 10 away from each other. And so if I multiply by a number, the spread, meaning the distance between the scores, get larger. Instead of only being 1 away, they're now 10 away. So our standard deviation changes except for when we add, okay? All right, so that's pretty important. So I'm going to do this. Okay, and then let's go to the next page here. So this last part that we're doing is called the 5-number summary. Let's zoom in a little more. So we're just doing the 5-number summary part today, and we'll do the modified box and whisker plot on the next lesson. So the standard deviation is a great way to measure the distribution of the data. So the spread of the data, that's also called the spread. When the data is normally distributed. If the data is skewed left or right, then the 5-number summary describes the data better. Okay? So we have to figure out how, what is a 5-number summary, right? What is a 5-number summary? So a 5-number summary involves 5 numbers. It involves what's called the first quartile, the median, which is also called the second quartile, the third quartile, okay, so these 3 quartiles, so the first, the middle, and the third, and it includes what is the lowest value, or minimum value, and then what is the highest value or maximum value. And so we have what's called outliers, which we'll learn later on. So it's not always the lowest score and the highest score. Sometimes we have these stray values that we have to ignore in our 5-number summary, but we still indicate that those scores happened, but it isn't part of us figuring this piece out. But that's for later. Okay. So our first quartile is the median of the first half. Okay, so it's the median. So let me highlight that. So quartile 1 is the median of the first half. Okay, but don't include the median, the actual median, to be part of any half of the data. Okay, because otherwise you're like not truly getting the middle. And then we already know how to find the median, it's that middle value, which we may or may not have to average. And then the third quartile is the median of the second half. Okay. So let's go ahead and look at this example just to make sure we get that. Okay, so here is an example. So make sure these are all in order, right? We want to make sure these are in ascending order, meaning from lowest to highest. So that's always something we need to make sure is happening. And so for the minimum value, I look to see what's my lowest. So here's my lowest. And then I look to see what's my highest value. And if it's in ascending order, it should be the last, right? So this would be my highest value. So pretty easy, right? So now to find my median, so I always find this guy first. So this is my first thing I find, this is my second, and then I find my median. So we're kind of jumping around here, I know, right? So this is the first thing I find, this is the second thing I find, and now I'm going to find my median, which is the third thing. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 values, so I'm going to count in 7. So right here, and then 7 this way. And so if I look, I have 2 things in the middle here, so 12 and 15. So that means I need to average, right, to find my median. So 12 plus 15, and then divided by 2. So my median is 13.5. So because 13.5 is not an actual data value, then when I find the median of the first quartile, I'm looking here. So this is, I look here at my first quartile, and I find what is the middle of that, right? So there's 7 values, so I'm going to count 3 in and 3 in. So this is my first quartile, because there's 3 numbers to the left and 3 numbers to the right. Okay? And there's my first quartile, or Q1, and then I do the same thing for the second half. So I look at the second half of the data, so that's just this part right here, and I count 3 in and there, so 1, 2, 3. So 3 to the left, 3 to the right. So then my third quartile is 21, because that is the median, or the middle, of the second half. Okay. All right, so let's take a look at example 2. So this is in order. So I find my minimum and my lowest and my highest value. So I'm going to do that first. So it's in order for me. So my lowest value is 10, and my highest value is 27. Okay. Now I want to find the middle. So let's count. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? So I counted 5 in both ways. And so 18, there's only one number in the middle, so that's my median, or Q2. So 18 is my median of all 11 data points. And so now I need to find the middle of the first half. So the middle of these numbers here, so 1, 2, so there's 12, right? So 12 is in the middle of all 5 values, right? 2 numbers to the left, 2 numbers to the right. So 12 is Q1. And do the same thing for the other one. Okay, so 1, 2, 3, 4, 5. Okay, so there's 5 values here, and so the middle will be 23. And there's my third quartile. Okay. All right, so what we're going to do here now is do one more here, but we're going to do and a box and whisker plot, okay? And figure out if we remember how to do that, okay? So first I want to make sure these numbers are in order, so I'm just going to go through and put all of these numbers in order. So I'm looking for the lowest value, so there's 84, and there's 2 of them, right? We always want to make sure we're in ascending order. And then 85, 1, 2, 3. So there's 3 85s. And then 86, 3 87s, and a 90. Okay. So we want to know what's our min, what's Q1, what's our median of the whole data. Oops, going off the page here. Q3 and our max or high. Okay. So our lowest value is 84. Our highest value is 90. Now I want to find the middle, so I'm going to just count here. So I went 5 in each way, and so there's no true middle, so then I have to average those two, right? And then for my first quartile, I look for the middle of these sets of numbers. So 85.5 is not a data set, so I get to use 85. So the middle of these 5 numbers is 85, so that's Q1. And then I look at the middle of these last 5, which is 87. And there's my 5-number summary, okay? So let's see if we remember how to do a box and whisker plot. Okay, so a box and whisker plot, so I'm going to scale down here. So I'm going to go from 84 to 90. Okay, so it's squished in there. So our box and whisker plot, I'm going to just plot these number values. So I'm going to put a dot above the 84, a dot above the 85, a dot above 85.5, above 87, and above 90. So I put the 5 dots as straight as possible as I could to get here. So our box and whiskers, we take the 3 numbers in the middle and we're going to create a box around those and then a line where the median is, right? So we take the 3 numbers in the middle, and you should have done this before, so this should look familiar. So the 3 numbers in the middle, you make a box around it, and then the line goes through here. And then the whiskers are to go to the max and to the min, okay? And that's a box and whisker plot.